Hi, this is an introduction to cations, anions, and how to write Lewis dot structures for ionic bonds. So we're going to start with just the atoms themselves, and we're going to look at how the atom wants to bond with another atom by looking at their valence electrons. So this chart here is just here to help us kind of get that started. So you'll need a periodic table with you if you don't already have one. So make sure you have one of those nearby. If you look at a periodic table, you'll see that the atomic symbol for chlorine is Cl, potassium is capital A, K, magnesium, remember those capitals and lowercase letters, and fluorine. And if you look at the total number of electrons, it's the same as the atomic number. So you're just looking at the number right above the element on the periodic table. This is the total number of electrons in that element. And we're looking at those. And fluorine is 9. Okay. Now, if you want to know the number of valence electrons, remember that is the number that's right before the A. So if it's a group 1A, it has 1 valence electrons, 2A is 2 valence electrons, 3A is 3 valence electrons, and so on. So if you look at chlorine, it's in group 7A, which means it has 7 valence electrons. Potassium is in 1A, so it has 1. Magnesium's in 2A, so it has 2 valence electrons, and fluorine again has 7. Now the valence electrons matter because that's where the bonding actually happens between atoms. Each atom wants to have a complete octet or full outer shell in order to be stable and have the lowest energy. So if you look at these numbers, they don't equal to 8. So we want to make sure that they equal to 8. Now, there's a couple of ways to get there. You can either add electrons or take them away, lose them, give them to another atom. And this is where bonding happens. So chlorine has 7 valence electrons and he wants to have 8. So he's going to gain 1 because gaining 1 electron is easier than trying to lose 7 electrons. Potassium has only 1 valence electrons in the outer shell, which means it's a lot easier for him to just lose an electron rather than trying to gain 7. Magnesium is going to lose 2 electrons because, again, it's a lot easier to lose in this case than to try to gain 6. And fluorine is going to gain an electron because that will make him closer to his octet. So if you look at this, chlorine, for example, has 17 protons. The protons never change, okay? And if he gains an electron, he has 18 electrons, which means his oxidation number will be -1 or 1 negative because he has more electrons now than protons because he gained 1. If you look at potassium, he lost an electron. He still has 19 protons. He only has 18 electrons, so his oxidation number is positive because the protons don't change and he got rid of an electron. Magnesium lost 2 electrons. He still has 12 protons. He only has 10 electrons, which means his oxidation number or charge is a +2. And fluorine got an electron, which means he has a -1 oxidation number. The oxidation number is obviously the charge of an atom, okay, after gaining or losing electrons to obtain a full outer shell. And the full outer shell is what happens that causes the bonding between atoms so that they're both stable. A full outer shell equals being more stable and lower energy. Okay, because that's the goal, is to be stable and to have a lower energy, and that's where the bonds come in. Okay, we've had enough practice with that. Let's move on to the next part of our lesson. Okay, let's answer these questions. If an atom gains an electron, he will have a negative charge. Again, electrons are negative. If he loses an electron, he becomes more positive, not because he gains proton, but because he loses that electron and the protons don't change. If he gains or loses an electron, he's now called an ion. not an atom so much anymore, but an ion. And an ion is an atom that where the protons do not equal the electrons. Okay, and that happens in bonding. A positive ion is called a cation, not cation, unless there's a VA in front of it and you're going on vacation. But a cation is positive. A negative ion is called an anion. All right. And you might remember cation because there's a T right here in the middle, and a T kind of looks like a plus sign or a positive sign. An anion is the same as saying a negative ion. And if you look at the A and negative and ion, it spells anion. Just a neat little trick there. So we've got cations and anions coming together to make ionic bonds. So now let's talk about how to make an ionic bond. Okay, an atom is going to transfer electrons, the protons in the nucleus never changes, to form that bond. Okay, each atom is left with a full outer shell, which equals lower energy. Okay, when you have an outer shell, that's what everybody wants to be, like the nobles. And an ionic bond forms between a metal ion that has a positive charge and a non-metal ion that has a negative charge. And if you remember the periodic table, this is a real rough diagram here. Your metals are here. You've got your metalloids along the aluminum ladder. Okay, so these are all your metalloids. And then your nonmetals are on this side. Okay, so an ionic bond has metals and nonmetals bonded together. Let's see how that happens. Okay, if we have sodium, sodium is our cation, and chlorine, you always put the positive before the negative. So we have the sodium atom, and we're going to draw our Lewis dot structures. Our chlorine, we already know, has 7 valence electrons, and remember when you're writing the dot structure, you kind of go in sort of a clockwise manner, enough so that each chair, for example, has its own set of, or own valence electron before you start sharing chairs. Okay, chlorine only needs 1 valence electron, and he can get that electron from sodium because sodium only needs to give away 1 valence electron. So then when you're done, you can see that chlorine has a full octet, and sodium also has a full octet, because when he loses an electron, he now has 10 electrons. And when you look at the periodic table, that is the electron configuration for neon. So he has a configuration like neon, which is a noble gas. So he's happy, chlorine's happy, and there you go. Now let's look at how we would write this. We have 1 sodium, cations are first, 1 chlorine, so you just write the formula. This is the chemical formula. Okay, NaCl. Now to name it, okay, the first one keeps the name like normal. He keeps his name just the way it was before. But the second one, you add the "ide" to the end. Okay, so in this case, you're going to call this sodium chloride instead of chlorine. So that's how you name it. All right, let's go and do another. Magnesium, cations are first, iodide. Now, if you were on a test, you wouldn't necessarily have these nice colors so you can tell whose electrons came from where. So on a test sometimes, or worksheets, you'll see that one of the atoms uses X's and the other uses O's, sort of like tic-tac-toes, but your O's are filled in. Okay, so let's look at that. Iodine has 7 valence electrons. And remember, when you're doing the dot diagrams, don't just use tiny little dots because it's hard for your teacher to see those. You actually kind of have to fill in these big bubbles. All right, so iodine is going to get this electron right here. This X represents magnesium's electron. So now iodine has a full outer shell. Uh-oh, there's a problem though. Look at magnesium on the periodic table. It's in group 2A, which means it has 2 valence electrons. He doesn't just give away 1, he gives away 2. So what does that mean? It means we need to add another iodine to the mix. So when you have magnesium in a solution with iodine, each magnesium ion will bond with two different iodines so that the iodines have full shells and magnesium has full shells. Again, if you look at the periodic table, magnesium after losing 2 electrons has 10 electrons, which again gives it the electron configuration of neon. Now his protons don't change, his neutrons don't change, so he's still magnesium in his identity. However, he has the electron configuration that's more stable of neon. So let's look at the formula. We're putting our cation first, our anion second. We only needed 1 magnesium. We keep an imaginary 1 here, but we needed 2 iodines, so we'll put a subscript of 2 to indicate that we needed 2 iodines with 1 magnesium in order to make the complete bonding of the ionic bond complete. Alright, so let's look at our name. The first one keeps the same name, magnesium. The second one has an "ide" added to the end. So we're going to say, instead of iodine, we're going to say iodide. And that's how you do ionic bonds with cations, anions, and the electron dot formulas. Good luck!